Jewelers abhor diamond impurities, but they are a bonanza for scientists. Safely encased in the super-hard diamond, impurities are unaltered, ancient minerals that can tell the story of Earth's distant past. Researcher Stephen Shirey of Carnegie's Department of Terrestrial Magnetism and Stephen Richardson of the University of Cape Town analyzed data from the literature of over 4,000 of these mineral inclusions to find that continents started the so-called Wilson cycle of breaking apart, drifting, and colliding about 3 billion years ago. The Wilson cycle is responsible for the growth of the Earth's continental crust, the continental structures we see today, the opening and closing of ocean basins through time, mountain building, and the distribution of ores and other materials in the crust. But when it all began has remained elusive until now. Scientists use the impurities, or inclusions, contained in diamonds because they are perfect time capsules from great depth beneath the continents. They provide age and chemical information for a span of more than 3.5 billion years that includes the evolution of the atmosphere, the growth of the continental crust, and the beginning of plate tectonics. The largest diamonds come from cratons, which contain the oldest rocks on the planet. Their roots, or keels, extend into the mantle more than 125 miles, or 200 kilometers, where pressures are sufficiently high, but temperatures sufficiently low, for diamonds to form and be stored for billions of years. The diamonds arrive at the surface during volcanic eruptions of deep magma that solidified into rocks called kimberlites. The inclusions in diamonds come in two major varieties, peridotitic and eglogitic. Peridotite is the most abundant rock type in the upper mantle, whereas eclogite is generally thought to be the remnant of ocean crust recycled into the mantle by the subduction or sinking of tectonic plates. The researchers found that before 3.2 billion years ago, only diamonds with peridotitic compositions formed, whereas subsequent to 3 billion years ago, eclogitic diamonds dominated. The simplest explanation is that this change came from the initial subduction of one tectonic plate under the deep mantle keel of another, as continents began to collide on a scale similar to that of the supercontinent cycle today. The sequence of underthrusting and collision led to the capture of eclogite in the subcontinental mantle keel, along with the fluids that are needed to make diamonds. The scientists concluded that this transition marks the onset of the Wilson cycle of plate tectonics. The Carnegie Institution has had over 100 years of extraordinary discoveries. To continue this tradition, Carnegie scientists need your support. For more information about this and other cool science, visit our website at carnegiescience.edu. This is John Strom.